Hello, my name is Ali Hassan, third year of Electronic and Communication Engineering at Nahrain University. Today we will be talking about DC motor electrical speed control. I have already did my research about it in the internet, and there were so much topics, videos and even lectures about this subject. We can't cover them all already, but we will try to give you the best conclusion of our subject. Hope you enjoy. The international change of drive speed is known as speed control of DC motor. So, if we are going to make a project needs us to control the speed of DC motor in it, then we will have to know how first. Speed control of a DC motor is either done manually by the operator or by means of an automatic control device. This is the different to speed regulation, where the speed is trying to be maintained or regulated against the natural change in speed due to a change in the load on the shaft, which it is N is equal to this equation, is equal to the terminal voltage of the armature, while RA is equal to the external resistance in armature circuit, while phi is the flux per pole. There is three ways of DC motor speed control. First, flux control method. Second, armature control method. Third, voltage control method. We will be explaining each one of them in this presentation. First, flux control method, shunt. As shown in the mathematical equations on the right side above, the speed of DC motor is inversely proportional to the flux per pole. Thus, by decreasing the flux, speed can be increased and vice versa, which means the opposite is right. To control the flux, a rheostat is added in series with the field winding, as shown in the circuit diagram. Adding more resistance in series with the field winding will increase speed as it decreases the flux. In shunt motors, as field current is relatively very small, I shunt multiplied with 2R loss is small, therefore this method is quite efficient. So, speed can be increased above rated value by reducing flux with this method. Second, armature control method shunt. Speed of DC motor is directly proportional to the back EMF of EB, and EB is equal to V minus IA and RA, the current and resistance of the armature. That means when supply voltage V and the armature resistance RA are kept constant, then the speed is directly proportional to armature current IA. So, if we added resistance in series with the armature, IA decreases and hence the speed also decreases. Greater the resistance in series with the armature is greater the decreases in the speed, an opposite relationship. Third, voltage control method, shunt. In this one we are going to have two parts of the method. A. Multiple voltage control. In this method, the shunt field is connected to a fixed existing voltage, and armature is supplied with different voltages. Voltage across armature is changed with the help of suitable switch gear. The speed is approximately proportional to the voltage across the armature. B. Ward-Leonard system. Ward-Leonard system speed control of DC motor. This system is used where very sensitive speed control of motor is required, like electric elevators, etc. The arrangement of this system is as shown in the figure at right. M2 is the motor to which speed control is required, while M1 may be any AC motor or DC motor with constant speed. G is a generator directly coupled to M1. In this method, The output from generator G is fed to the armature of the motor M2, whose speed is to be controlled. Now we will be talking about flux control method series. We talked about it when it was in shunt, now in series. This one is going to be in 4 parts. First, field diverter. A variable resistance is connected parallel to the series field as shown in figure A. This variable resistor is called a diverter, as the desired amount of current can be diverted through this resistor. So, the current moves through the field of the coil, which can be decreased, while flux can be decreased to the desired amount and the speed can be increased. Second, armature diverter. Diverter is connected across the armature as shown in figure B. For given constant load torque, if armature current is reduced, then the flux must increase. This result will increase in current taken from the supply, and hence flux will increase, and then speed of the motor will decrease. Third, tapped field control. As shown in figure C, field coil is tapped dividing number of turns, so we can select different value of phi by selecting different number of turns. Fourth, paralleling field coils. In this method, several speeds can be obtained by regrouping coils as shown in figure D. Second, armature control method. Variable resistance, series. By introducing resistance in series with armature, voltage across the armature can be reduced, and hence the speed reduces in proportion with it, as you can see in the figure below. Third, series parallel control. This system is widely used in electric traction, where 2 or more mechanical coupled series motors are employed. For low speeds, the motors are connected in series, and for higher speeds, the motors are connected in parallel. When in series, the motors have the same current passing through them, although voltage across each motor is divided. When in parallel, the voltage across each motor is same, although the current gets divided. This was the last slide of our video. Hope you enjoyed watching it. Wish you a great day. All the best.